Hello everyone, I am Dr. Guangyao Chen and this is Aviation Physics. Today we begin chapter 7, where we will explore the 4 fundamental forces that act on an airplane in flight. When an airplane is flying, it's subject to 4 fundamental forces: lift, weight, thrust, and drag. These forces are in constant dynamic interaction that determines the airplane's motion. Pilots have direct control over lift and thrust, while weight and drag are inherent factors that influence the plane's stability. Here is a cartoon illustrating of the direction of the 4 forces. Let's start with the most intuitive force, weight. All objects have weight, which is a measure of how heavy or light they are. This force is a direct result of the Earth's gravity pulling down on the object. The Earth's gravity pulls acting on everything, including an airplane in flight. In order for an aircraft to take off and climb, the upward force of lift must be greater than the downward force of the plane's weight. Looking at those two aircrafts, Plane A and Plane B, Plane B is clearly larger and weighs more than Plane A. So how much lift will Plane B need to get off the ground compared to Plane A? The answer is B, more than A. That's right, a heavier plane requires more lift to overcome its weight. The weight of an airplane is a primary factor in determining how much lift is needed for it to fly. This concept is formally described by Newton's law of universal gravitation. It states that any two particles in the universe attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The formula is gravitational force equals G m1 m2 divided by r squared. The capital letter G is called a gravitational constant. G is a fundamental physical constant that has the same value for any two particles, and its unit is this. Using estimation for the mass of two footballs, roughly 0.5 kilogram, and the distance between them, roughly half a meter, the gravitational force is found to be tiny, on the order of 10 to the minus 11 Newton. This tiny force would produce a practically unobservable acceleration, making the gravitational attraction between them impossible to detect. When an object is at the surface of the Earth, we can simplify Newton's law to calculate its weight. The weight, noted as W, is a gravitational force. Fg is a gravitational force exerted on the Earth and from the Earth and object is calculated using the law of gravitational gravity. And we need to use the mass of the Earth, mass of the object, radius of the Earth to do this calculation, and we would find the G that we are familiar with, which is 9.8 meter per second square on surface of Earth. Action is calculated from this gravitational constant g, mass of the Earth, and the radius of the Earth. This graph clearly shows that an object's weight decreases as its altitude increases. As an astronaut moves further from the Earth's surface, the distance r from the center of the Earth increases. According to Newton's formula, since r is in the denominator, a larger r results in a smaller gravitational force, or weight.